Hi, welcome to my video on K-nearest neighbors. Nearest neighbor search is a core component of information retrieval, search, and ranking systems. We look into exact and approximate nearest neighbors and implement the exact algorithm from scratch in Python. Let's get started. Let's start with the goal of k-nearest neighbors. Given a query data point q, we want to find k closest points from the training set D to the query point. Let's call the set of nearest neighbor points nk. K-nearest neighbors is a supervised ML algorithm used for classification and regression tasks. Let's look at the KNN classifier first. For KNN classification, the labels are discrete. Given that we found our nearest neighborhood of points, to determine the output label y, we take the majority vote of the k-nearest neighbor labels. For example, for k equal to 6, if we have 1 vote for class 1, 2 votes for class 2, and 3 votes for class 3, the majority vote is equal to 3. For KNN regression, the label is continuous. Given the nearest neighborhood of points, to determine the output label y, we take the average of k nearest neighbor labels. For example, for k equal to 3, if we have nearest training labels -1, 0, and 4, the KNN output label is the average of these values and it's equal to 1. To make things a little more concrete, let's take a look at the pseudocode for the exact KNN regressor algorithm. Here we have a function KNN search that takes in the parameter k, the training dataset x, and the associated training labels y, and the query or test points q. For each query point, we do the following. We compute the distance, in this case Euclidean, between the query point and all the training points in the dataset. Then we sort the distances from the smallest to largest and select top k nearest neighbor indices. This step takes big O of nd plus n log n time to complete because computing distances between nd dimensional points takes nd time and sorting takes additional n log n time. Having found our k nearest neighborhood, we extract the training labels and compute our predicted labels as the average of the training labels in the nearest neighborhood. Before we go into implementing the pseudocode in Python, let's take a look at approximate nearest neighbors. There are three main types of approximate nearest neighbors: tree-based ANN, locality-sensitive-hashing, LSH-based ANN, and clustering-based ANN. The aim of approximate nearest neighbors is to reduce the search complexity of the exact algorithm. Since the input space is usually very large, approximate nearest neighbors are often used in practice. In tree-based ANN, we form a tree by splitting the space into multiple partitions. Non-leaf nodes split the space into partitions, while the leaf nodes indicate a particular region in space. ANN algorithm only searches the partition that the query point belongs to. In the diagram below, we have a two-dimensional example, and if our query point falls in region 2, described by x1 less than 0.4 and x2 less than 0.2, then we only search for nearest neighbors in region 2. KD trees are commonly used to partition the space into regions. In LSH-based ANN, we use hash functions to map points in close proximity with each other into the same bucket. Then we only need to search for points belonging to the same bucket as the query point q. In clustering-based ANN, we first form clusters by grouping points based on similarities. Then we only search the subset of points in the cluster to which the query point belongs. Now that we have a better idea what nearest neighbors algorithm is about, let's take a look at a Python notebook where we'll implement the exact KNN regressor from scratch. This notebook is linked in the video description below. Let's start by looking at the Python implementation. We start by importing NumPy and matplotlib and fixing the seed for reproducible results. We define the KNN class and initialize the parameter k in the constructor. Next, we define a function for computing the Euclidean distance between 2 points. In KNN search function, we take in the training data xtrain, training labels ytrain, and the test or query data q. Next, for each query point, we compute the distance between the query and all the training data, sort the distances in ascending order, and take k nearest points. After that, we extract the KNN labels and finally compute the average as the output of KNN regressor. Let's generate our training data as a noisy sinusoid computed over the interval from 0 to 5. We set k equal to 8, initialize our KNN class, and predict the label data. We can see the KNN predictions as the average of k nearest neighbors. I hope you have a better understanding of the k nearest neighbor algorithm. Thank you for watching. If you like this video and are interested in more ML educational content, please hit like and subscribe. Looking forward to seeing you soon.